Yes, my dear students of 10th standard, nowadays we are discussing about the nomenclature of organic compounds. Nomenclature of organic compounds in the lesson Carbon and its compound, Unit 11, which is your chemistry portion of science. And in the nomenclature, how the names of organic compounds are derived. In those days, in ancient days, the names were given from which they were obtained, from their original source. For example, formic acid. Formic acid, the name is given based on the original source, that is formica. Formica means red ant. In those days, formic acid was obtained by the distillation of red ants. But after that, scientists prepared different organic compounds by synthesizing. So scientists framed a systematic method for naming the organic compounds based on their structure. So a set of rules was framed by the International Union of Pure and Applied Chemistry. Actually, there are three important parts, components in the IUPAC naming. First one root word, second one prefix, third one suffix. All this already we discussed. Once again we do revision. So root word based on the basic unit, that is the base of the carbon skeleton. How many carbon atoms are present in the given organic compound? Suppose 3 carbon atoms are there, then we can say the root word prop, 5 pent, like that, based on the Greek numerals. Then prefix, that is the term or the phrase before the root word, the beginning of the organic compound. Then that is based on the substituent. What is called substituent? Atoms or group of atoms other than hydrogen attached to carbon. That is called substituent. Example, some examples are given here in the table 11.4. Fluoro, chloro, to fluoro F, symbol F is used, chloro Cl is used, bromo Br is used, the dash that denotes the bonding with the carbon atom, the bond with the carbon. Similarly, amino, methyl, ethyl, these are the some of the prefix used in the organic compound. Then suffix is nothing but that is the end of the name of organic compound, that is the end. There are two parts in the suffix, primary suffix, secondary suffix. Primary suffix normally denotes the bonding between the carbon atom. Bonding, whether the bond is single or double or triple. Single bond means the suffix will be A-N-E, double bond means E-N-E, triple bond means Y-N-E. The secondary suffix normally denotes the functional group of the organic compound. For example, alcohol, functional group is OH, then the suffix will be, the end of the name will be OL, alcohol. Aldehyde, functional group is CHO, the end will be AL, alkanol. Ketone, ONE, example propanone. Carboxylic acid, COOH is the functional group, example propanoic acid, butanoic acid. So the suffix will be end with OIC acid. So those things were already we discussed. Now we are going to study about the rules for naming organic compounds. There are 6 rules are given. Basically, the first 3 rules are very important. So all these rules are based on the components of IUPAC. What are the 3 important components? Root word, prefix, suffix. So you have to clear about these 3 terms. Root word is nothing but that describe the carbon skeleton, the number of carbon atom present in the parent chain. The number of carbon atom present in the parent chain. Then already prefix is a phrase before, that is based on the substituent. Then suffix is the phrase afterward, that is the end of the name, that is based on the bonding between carbon and the functional group. So first to see in the rule 1, first we have to identify the longest chain of carbon atom. So we have to number the carbon atom to get the root word. The root word, that is the parent hydrocarbon, can be obtained by giving number to the longest chain of carbon atom in the compound. For example, you can take here, say example 1, CH3, CH2, 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 CH3. There are 5 carbon. There are 5 carbon. It is a open chain compound, a cyclic compound, and it is a saturated compound because there is a single bond between the dash denote single bond between the carbon atom. And how many carbon? 5 carbon. 5 carbon means the root word is pent, P-E-N-T. That is the rule 1. So we have to check, we have to identify the longest chain of carbon. And also see in the second example also it is given. See, you can take the longest, the linear pattern of carbon skeleton. There are 5 carbon. There are 5 carbon. See, there is a branch with the second carbon that we have to consider as a substituent. That is called a substituent. Then 5 carbon. So root word is pent. Root word is pent. Then what is the second rule? Number the carbon atom of the parent chain. We have to give number. We have to give number. From which side to start, whether it is left hand side or right hand side, that is based on the presence of substituent or functional group. Suppose substituent only present means that substituent with the carbon should get lowest possible number. So see this example 2, CH3, CH, CH2, CH2, CH3. With the second carbon, one CH3, that is a methyl group, is attached. So that methyl group should get lowest possible number. So we have to start numbering from the left hand side. From left hand side. So the left hand side, first carbon, then second, third, fourth, 5. So the second carbon methyl group is attached. So such a way we have to give number. Suppose a functional group is attached. Functional group is attached. That functional group also get lowest possible number. If both the functional group and substituent both are attached, what will we have to do? So we have to give preference, the priority to the functional group. First we have to give preference to the functional group, then next substituent. So that is second rule. First rule is we have to identify the longest chain of carbon skeleton. Then second rule is numbering the carbon atom. Numbering the carbon atom based on the presence of functional group or substituent. And third one, in case of alkene, alkyne, suppose alkane, that is end with the A and D, that possesses only single bond. Alkene double bond, alkyne double bond. alkene double bond, alkyne triple bond. So the double bond, triple bond, see, when we are going to give the local number followed by a dash and the primary suffix, the carbon chain is numbered in such a way that the multiple bond should possess the lowest possible local number. So we have to give the local number that should give the lowest possible number to the double bond or triple bond attached with the carbon. We have to check where, from which carbon the double bond is attached or triple bond is attached. The double bond, triple bond attached carbon should get lowest possible local number. Such a way we have to number the carbon atom. Then rule number 4, if the compound contains functional group, we have to give local number that functional group should possess lowest possible number, and also we have to mention the functional group by giving a dash. The dash refer that is the bonding secondary suffix and secondary suffix. So priority should be given to functional group followed by secondary suffix. Then fifth rule, when the primary secondary suffix are joined, then the terminal E of the primary suffix is removed. Suppose a pentane, that E is going to be removed. Then sixth one, identify the substituent. We have to check whether the carbon skeleton contains substituent or not. If the substituent is there, we have to identify and use the number, local number, using dash. The dash for the bonding between the substituent with the carbon and a prefix to specify its location. So there are 6 rules. Out of these, first 3 rules are very, very important, because from this we can name the organic compound. First we have to identify the longest chain to get the root word. Second one, number the carbon atom based on the presence of functional group or substituent. Third one, we have to give lowest possible number to the double bond carrying carbon or triple bond carrying carbon. Triple bond carrying carbon. And you can see some examples. See, in the first one, see, there are 5 carbon. This is a simple pattern, open chain compound, saturated compound. Saturated compound means having single covalent bond between the combining carbon atom. Single bond. The dash for single bond. So 5 carbon. 5 carbon means, according to the Greek numerals, 5 refer penta. So the root word is pent. So it is a saturated compound. So end with the ane, pentane. Pent plus ane, pentane. Saturated hydrocarbons end with the ane. So pent is the root word, ane for saturated hydrocarbon. When you are going to combine, you will get pentane. This is a normal pentane. Sometimes we also used to write N-pentane. In the higher classes, it is given N-pentane. N means normal pentane. Normal pentane means there is no branch, there is no substituent, there is no functional group. So it is called the normal pentane. Then see the example 2 here. There are 5 carbon in the linear carbon skeleton, but with the second carbon, one substituent is attached, that is CH3. That CH3 is nothing but methyl. That group is called methyl group. How to number the carbon? we got to give number to the linear pattern of carbon skeleton. So 5 carbons are there. From which side we have to start? We have to start from the left hand side. Why? Because the substituent should get lowest possible number, lowest possible local number. So when you're going to start from right hand side, that substituent going to get not lowest possible number. You will get 1, 2, 3, 4. 4 will come. But when we start from left hand side, that substituent going to get lowest possible number 2. Lowest possible number 2. So we have to number the carbon atom from left hand side. Then here only single covalent bond is existing between the carbon atom. Single bond. Single bond means saturated hydrocarbon, saturated compound. Saturated compounds are end with ANE. ANE. Suffix is going to be ANE. And we have to check whether any substituent or functional group. There is a substituent with the second carbon. There is a substituent with the second carbon, that is methyl. Methyl. That methyl is attached with the second carbon. So we have to write 2 because the 2 refer the second carbon. 2 dash methyl. 2 dash methyl. And what is the parent skeleton? Pent, because 5 carbon. 2 methyl plus root word pent plus it is a saturated hydrocarbon, so end with the ANE. So 2 methyl plus pent plus ANE. When you are going to combine all this, you will get 2 methyl pentane. 2 methyl pentane. Then similarly, you can take one more example. Here see, there are CH3, CH, CH2, 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 CH3. This is the linear pattern. Linear pattern. And in the linear pattern, there are 6 carbon. There are 6 carbon. But we have to find out the longest chain. Longest chain. So to find out the longest chain, so we have to take the next substituent. The substituent also going to be considered for the carbon skeleton. So CH3, CH2, CH, CH2, 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 CH. So this pattern is considered because this is going to be a longest chain compared to the previous one. Compared to the previous one, this is going to give a longest. So we have to identify the longest carbon skeleton, which give the longest carbon skeleton. So another one pattern is given, that is wrong because it's going to give only 6 carbon. The other above pattern going to give 7 carbon, which is the longest. The above one is longest compared to the below one. So we are going to take the above one, that is the correct way of numbering the carbon atom. 7 carbon attached. So 7 carbon means, according to Greek numerals, 7 refers hepta. Hept. Hept is the root word. Hept is the root word. H-E-P-T. Hept is the root word. And we have to check, is there any functional group or substituent. There is a substituent with the third carbon, that is methyl CH3. CH3. Methyl group is attached with the third carbon. So we have to write 3 methyl plus root word hept, and there is a single covalent bonding between the combining carbon, saturated compound. So the suffix is going to be ANE. ANE. So prefix is 3 methyl, root word is hept, and suffix is ANE. So when you are going to combine 3 methyl plus hept plus ANE, 3 methyl heptane. 3 methyl heptane. And also we can take one more example, that is CH3 single bond, CH2 single bond, CH2 single bond, CH double bond, CH2. Double bond is given here. So first we have to check up according to the rule 1. Find out the carbon skeleton. How many carbon? There are 5 carbon. There are 5 carbon. 5 carbon mean according to Greek numeral, root word is penta, pent. And it is bonded, the carbon atoms bonded with another carbon using double covalent. So it is not saturated hydrocarbon, it is unsaturated hydrocarbon. So it is a type of alkene. Double bond means alkene, end with ene, suffix is going to be ene. Double bond means the compound will end with ene. Suppose a triple bond means yne. Here double bond is given ene. So the carbon chain numbered from the end, the double bond should get lowest possible number. So we have to start to give the number carbon atom from the right hand side, then only the carbon having double bond will get lowest possible local number. So from right hand side we have to give number. So 1, 2, 3, 4, 5. Then that carbon contain double bond will get the lowest possible number of 1. With the first carbon, double bond is attached. With the first carbon, double bond is there. So that root word is pent. And with the first carbon, double bond is located. So 1 dash ene, pent plus 1 dash ene, that is pent 1 ene. Sometimes we can also write 1 pentene, 1 dash pentene, or pent dash 1 ene. Different ways are there to write the name based on the IUPAC pattern. So my dear students, so you have to understand, first we have to identify the longest chain of carbon atom to find out the root word. Second one, numbering the carbon atom based on the substituent or functional group. Both the substituent functional group is present, we have to give priority to functional group. Then double bond, triple bonds are present. The double bond, triple bond contain carbon should get lowest possible number. Such a way we have to give number to the carbon skeleton. So this is the basic method to write the IUPAC name for the organic compound. So there are different examples also there to write IUPAC name for the organic compound. Next class you will see how to write IUPAC name for the other elements, other compounds having functional group alcohol, ketone, aldehyde, like that. So you have to practice whatever you learn. Learn these 6 rules. Try to apply these 6 rules to write the IUPAC name. Next class you will see, you will get more examples to understand this naming of organic compound based on the IUPAC pattern. Till you prepare well, don't waste the time. Thank you. God bless you.